Today's lab is the types of chemical reactions lab. You should already have a paper just like this before you begin this video that you'll be filling in. I will go into the stations in order, so if you start at station number 1 and just number it all the way down to 5, you should have no problem filling this in. You want to note all of the chemical reactants that you're working with, all of the chemical products that you produce from these reactions, and then we're also going to make some observations. So when you're watching me do the actual reaction, you need to make some observations and be detailed about it. And I will be explaining everything that I'm observing, so you take note of it on your own paper. After the reaction's done, you're also going to make some observations, take a look at what the chemicals look like after they've done something, and any other things that I make comments on throughout the reaction, or after it too. You tell me what type of reaction from the 5 that we've learned, and then you also tell me what indicator of a chemical change there is. You need to look back at your pre-lab questions and see which of the 4 is going on during this reaction that will indicate to me that a chemical reaction is occurring. Station number 1. We're moving down to here. We have a description of the reaction. Let me see if I can zoom out a little bit. Observe the solution of copper 2 chloride and sodium hydroxide located in the beakers. So that's what we're going to do. Here is my sodium hydroxide solution. Looks just like this. Alright, it is dissolved in water, so keep that noted. It is aqueous. We come over here to the copper 2 chloride, and this is what it looks like. Looks like bluish water. It is aqueous. Looks pretty clear. I can see the pipette no problem. And now we're going to continue on with the procedure. It says to take 1 clean test tube, which we have right here in my test tube rack, and we are going to add some drops. We're going to put 5 to 10 drops of copper 2 chloride and 15 to 20 drops of sodium hydroxide. I am too impatient. I just do squirts. There's a squirt of sodium hydroxide into my test tube. Here is a squirt of, watch the solution, it looks like water, right? Sodium hydroxide. Now I add my copper 2 chloride. You should notice a change here. I bring my test tube up, you look closely at it. Let me shake a little bit. It looks almost like you have solid particles sitting in there. I don't notice any temperature change, and actually if I shake it up a little bit more, mix it all up, it's got a nice blue color to it, and it actually kind of looks like a blue gel that formed. It's thick. It doesn't look like that clear water. You can see it's completely opaque. You can't see right through it like the copper 2 chloride. So we got a number of observations that are going on here. Hopefully you're getting good stuff. Don't forget you can always rewind. You can see some of the crud that's left over. Like I said, it looks like almost like blue gel that's left over when they both react. So we definitely have a chemical reaction that took place here. Solid substance came out of solution. There it is. Again, did you want to compare? See the copper 2 chloride? And then our product afterwards. Now we got station number 2 to deal with. Station number 2 is a fairly simple procedure. And if we zoom on in here, what we're going to observe is a piece of steel wool. Alright, looks kind of like this guy right here. Same old stuff that you can buy at the grocery store. I don't know, maybe you can, I don't know. I think you can. I've never really bought steel wool at the grocery store, but I think that's there. People got to wash their pots and pans somehow. Alright. So what we want to do here is to make some observations. So we have steel wool, which is also known to have iron in it. It says make sure that your lab papers are out of the way in the area surrounding the Bunsen burner. Using a pair of crucible tongs to hold the steel wool, turn on the Bunsen burner and put directly onto the top of the flame. Okay, no problem. Let's go. Let's do this. Got my Bunsen burner. Start it up. Yep, my gas is just a tad high, and there's a breeze in here. I'm going to take my steel wool with my crucible tongs. Alright, you notice that steel wool is a solid at room temperature. Alright, it's not flowing out of the tongs, and let's watch what ends up happening here as I place it in the flame. Whoa! Totally have sparks flying. This is so funny because you're going to be on camera with your clicky like that. Now I'm going to let this sit there and cool off on the tabletop. You can totally see a color difference here. See how the original steel wool that really actually didn't burn is right there. As you can see, I don't want to stick my finger. You can see it right there by the tip of my finger. This is all reacted, so I could tell that because, well, something changed. But you can also see that there is a color change. We got to keep in mind it did burn, so in order for things to burn, something else has to be present. So it wasn't just iron reacting in a flame, it was iron reacting in a flame with some other chemical that must be in the air. So big hint there. Alright, reaction number 3, station number 3. I got a Bunsen burner already going. Got some nice combustion going on right there. But anyway, I started it up and we have a chemical called sodium hydrogen carbonate. It looks something like this. Take a look. Sodium hydrogen carbonate. It's a white crystalline solid. It's just sitting inside this test tube, sometimes called baking soda. You can buy it at the grocery store. It makes cookies. Delicious. Well, actually, it doesn't make them delicious. It makes them, well, puffier. So what we want to do is, in this procedure, it says that we are going to take one test tube. We're going to have a sample in it already. And we're going to take some test tube holders, just like so, and I'm going to pinch this test tube. We want to cook it. It says to gently heat for about 30 seconds, and after that 30 seconds of heating, we're going to turn off the Bunsen burner and place the flame of a wooden splint in the opening and observe what happens. Place the test tube containing the baking soda in the test tube rack, labeled used. Alright, wonderful. So we got a used one over here. That's where we're going to put it. A lot of used. So let's heat. Place in that flame and we're heating. We're going crazy. Look at it heat. Alrighty, so we're heating and heating and heating, and eventually what ends up happening, we get this so nice and hot that a reaction takes place. We start cooking this stuff. If you can see it, you might start to see some, let's not catch the camera on fire, water vapor showing on that test tube. You might see some little droplets. That's what you're seeing right there, is little droplets of water starting to accumulate, especially at the end of the test tube. You see that? That's nice. So we're definitely seeing some water, but there's also a gas that we cannot see. Let's zoom out. Let's test that thing out. Last thing, let's test out to see what happens here if I take a lit splint and put it into this test tube. So watch closely as I put it in. It puts it right out. What the heck is that? A gas that is being produced from this heating of this white powder is having no problem putting that flame out. What could that possibly be? Can you think about it? Out of the 3 gases that you were talking about in your pre-lab, what are the gases that must be coming out of sodium hydrogen carbonate? As another hint here, we also tell you that there is water vapor being produced, and then there is also a chemical called sodium carbonate. The white powder that you see here, you might notice some other coloration changes. That's coming from the wood. Alright, it's not the sodium carbonate. Sodium carbonate is still a white in color, and that's what's present right now in that test tube. And again, we got plenty of water vapor. That's one of our products. Water vapor, sodium carbonate, and some gas that you're responsible for figuring out. Station number 4 is our next reaction. I'm going to step over here in this lab station. I got a number of things to work with. I got an empty test tube. I got a solution of dihydrogen dioxide. As you can see, it looks very much like water. Actually, it's an aqueous solution of dihydrogen dioxide. It's been dissolved in some water. It's actually mostly water. But there is a little bit of that chemical sitting in there. Dihydrogen dioxide is also known as hydrogen peroxide, as you can see in the instructions. We also have another chemical called a yeast catalyst. Catalyst is just a material that's going to help aid in the production of our products. So it's going to help to speed it up. I got some wooden splints here to do a wooden splint test, and I also got my little cheapy lighter that I bought at Drug Mart. Alright, so to start off, it says to obtain a test tube with a small amount, alright, about an inch of up the test tube. So I'm going to take my solution, suck it up, put it in my test tube, suck up some more. Alright, a little bit more. Alright, so I have my test tube filled up about an inch. All right, looks like water again. Again, dihydrogen dioxide sitting in the test tube by itself. Looks like liquid water. It's just an aqueous solution. Again, the catalyst is sitting in this beaker. It says to add about 5 drops of catalyst to this. And then we're going to be messing with a wooden splint in a second. So again, it says that we're going to place 5 drops of this catalyst solution in the test tube that contains the peroxide. So let's watch what ends up happening. Nothing's really happening at the moment, but when I add my 1, 2, 3, 4, 5. Whoops. Let's shake it up a little bit. Shake it up, right? When we shake it up, we definitely see, if we look closely, we definitely got bubbles going on. So I'm going to keep shaking a little bit more just to mix up the catalyst with my chemical. And I'm going to mess with a wooden. Alright, so I caught that on fire. I'm going to blow it out. Oh, come on. This is very flammable wood. Alright, now, if I'm lucky here, let's see what ends up happening. We want to test out to see what gas is present. So here it goes. If I turn it in there, look at that go. Do you see that? Man, it's getting brighter. It's not exploding, but it's definitely getting brighter. If I stick it right there, you see that brightness. Got more intense. If I pull it out, not so intense. But if I pull it back in, intense. Alright, cool. Alright, that's enough. So, we got 3 gases that we should be aware of. So, one of these gases does something to wooden splints. We just saw it reignite and glow brighter. So, think about which gas is present in this reaction. Alright, if you still don't know, Google it. Alright, you probably will figure out what the gas should be. So you can totally see that we have gas bubbles going like crazy now. It looks like fizzy water. Filling up that test tube full of gas. And we notice that there's still liquid sitting at the bottom of the test tube. So think about the products that could be possibly coming from this reaction. Alright, the next reaction, station number 5. In station number 5, we're going to be working with 2 chemicals. One is hydrochloric acid. It's an aqueous solution of hydrochloric acid. It's been watered down. If you have pure hydrochloric acid, it's normally a gas at room temperature. So we have an aqueous solution, and I'm going to show it to you in a second. We're also going to be working with zinc. The zinc is sitting over here, so let's take a close look at the zinc. That's zinc right here. As you can see, the zinc, it's solid. It's pretty dull in appearance because it's oxidized slightly. But that is the metal right there. It's all gnarly looking, but it is solid at room temperature. Here is my hydrochloric acid sitting in a test tube. As you can see, it looks very much like water. Now, what we're going to do is place a piece of zinc into that test tube. So I take my little forceps, take a piece. This is very hard to do with a camera in front of you. There it goes. Bring it on over here, and we're going to drop it in. Let's see what ends up happening. When I drop it in, we immediately start getting bubbles, and it's very vigorous. Alright, so zinc is reacting with that hydrochloric acid very well. We can definitely see an evolution of gas bubbles. And if you want to, you can actually feel the test tube. You can't feel it, but I can, and it feels warm to the touch. So it's giving off energy. Exothermic reaction. Alright. Anyways, the next part of the procedure says to take a test tube and invert it. So we're going to take a test tube that's sitting over here. Hopefully this will work. It's got liquid in it, of course. Do I have any dry ones? This, I guess, will work. I'm going to place it right over the opening of the test tube to invert it. We're going to collect some of the gases. So I got this gas sitting in this test tube. He's going to move it over to the open flame, and let's see what ends up happening. You move it, because I can't see. Oh, we had a nice pop right there. It was nice and explosive gas. I'm going to blow out my flame. Go ahead and put it down. As you can see, the reaction's still going on. It's still bubbling. And we definitely had a gas produced there, so we got to figure out what gas that was from this reaction. Zinc and hydrochloric acid produces a gas that's explosive. We had a nice pop. Alright, so you guys figure it out. You're putting this all into words. You're taking everything that you did in the beginning, putting all the words for the reactants and the products right here. Chemical equation should include the chemical formulas, the physical states for each chemical, and then any other special things that have to be going on during the reaction that should be placed over the arrow, such as any heat or catalyst used for each reaction.